Welcome to the physics class. In this lecture, we will study about rounding of digits and algebraic operations with significant figures. So first with rounding of digits. So there are four rules in rounding of a digit. The rule number 1, this states that if the number lying to the right of the cutoff digit is less than 5, then the cutoff digit is retained as such. However, if it is more than 5, then the cutoff digit is increased by 1. So what it means by cutoff digit is that the last digit that is retained is called cutoff digit. So in this case, we have to round this number 7.23. So we have to round this to 2 digits. So this is 1 will be the last digit, so this is called the cutoff digit. And since the number to the right of cutoff digit is less than 5, so 7.2 will only remain. So we have 7.2. Now in this figure, the cutoff digit is 2 and the digit to the right of 2 is 8, which is more than 5, so we will increase 2 by 1. So we have 5.33. 5.3 as the round of digit. Now rule number 2 states that if the digit to be dropped is 5 followed by digits other than 0, then the preceding digit is increased by 1. So in this example we have 14.352 in which 5 is appearing here. We have to round off this number to 3 digits, 3 significant digits. So we will increase 3 by 1, so it will become 14.4. 14.4. Now rule number 3 states that if the digit to be dropped is simply 5 or 5 followed by zeros, then the preceding digit is left unchanged if it is even. So if we have, for example, 6.250 or 6.25, so we see that the preceding digit to 5 is 2, which is even. So we will leave it as such and we will round it as 6.2. Now rule number 4 states that if the digit to be dropped is 5 or 5 followed by zeros, then the preceding digit is raised by 1 if it is odd. So in this figure, this is 6.350 or 6.35 we can take. In this we have the 3, this one is odd number, so it will be increased by 1. So we have 6.4 as the significant figure. Now let's move on to algebraic uh, operations with significant figures. So suppose we have this 1.2 plus 3.45 plus, I'll zoom it a little bit. We have 1.2 plus 3.45 plus 6.789. If we calculate this will calculate as 11.439. But this is not a good answer when we are just given as 1.2 figure with two significant figures in this count. So if we call this a chain, if we call this a chain, then the uh, least weighted numerical uh, least weighted digits will be counted as the number of significant figures in which we have to give the answer. So in this we have 1.2 as the least weighted digits significant figure. So we have 11 point. So we have 11.11, just 11 we have. So in this example we have 11.4 as the significant figure, because the least number of significant figures after the decimal is 2, that is 1, that is only one digit is there after the decimal. So we will give answer as 11.4. Now after that we have this example 12.63 minus 10.2 will give us 2.43, but we have only one decimal place after the decimal. We have only one digit here, so we'll give answer as 2.4. Now after that multiplication or division. If we want to multiply 1.2 with 36.72, then the answer will come as 44.064, but we will give answer as 44.0. Okay, so it seems like I have made a mistake here. The number of significant figures that we should have in this quantity should be 11, because this should not be the point 4 would not come, because we have 1.2 and in this we have just 2 significant figures, so 11 will come. In this one we have 3 significant figures, so 2.43 will come. In this one we have 2 significant figures, so we will have 44 as the answer. Now in division we have 3 significant figures, so the answer will be 107, but this 9 is here, so it will make this 7 8. So we have to see that we are also rounding off the digits before we apply significant figures. So in this the answer is 108. Now we'll do an example. The radius of a wire is 2.50 mm. The length of the wire is 550.0 centimeter. If the mass of the wire was measured as 25 grams, then find the density of the wire in correct significant figures. Given where pi is 3.14 exact. So pi we had studied earlier in the earlier lecture that it has infinite number of significant figures. So we are given r equal to 2.50 mm. First we will convert all the units in SI units. So it is 2.50 into 10 to the power minus 3 meters. Then we have L equals to 50.0 centimeter. I'll write that into 0.500 meter. Why I have written two zeros here is because we have three significant figures here. So we will have three significant figures in millimeter also. So changing units in any measurement does not change the significant figure in that measurement. Mass we are given 25 grams, so we into kg it will be 0.025 kg. The formula for volume is pi r square L. Because it is a wire, I'll make a wire here and like structure here. So this is the wire for which we are measuring the density. So the formula for density is equals to mass by volume. Mass we are given 25 into 2.5. 2.5 into 10 to the power minus 3. So there is a point here and point here. This is 2.5 into 10 to the power minus 3 divided by pi into 2.50 into 10 to the power minus 3 whole square. This is the r radius. This is the radius, and this is the L length L. This is length L. Now after this we are left with, when we calculate the denominator, it will come as 9.81 into 10 to the power minus 6. That is, if we calculate this whole figure, it will come as 2.54841998. So this is a very large value, number of digits. We just, the least value in which the significant figures was there was 2.5, that is 2 digits. So we are just take significant figures as 2. So we have 2.5 into 10 to the power 3 kg per meter square. So that is the density of the, density of the object. Correct to two significant figures. Correct to two significant. I know that you won't be seeing this. You can see it. I have written here this. Okay, so that was all for today. If you have liked the video, please do like the video, subscribe to my channel and share it among your friends. Thank you.